Hi there. Today I'll be showing you how to use the SBOM Workbench, which is a graphical user interface to scan and audit source code using the SCANOSS API. On the GitHub repository here, as you can see, auditing your source code for license compliance has never been easier. Simply scan your source code directory to find and identify any open source components, generate your SPDX-Lite software build of materials with the press of a button. That's exactly what we'll be doing today, so let's get started. So the first thing we need to do is actually install SBOM Workbench, and the way to do that is simply head over to the releases section in the top right hand corner here. Click on the latest release, which is 1.3.9.0, and basically scroll down and download the relevant installer for your system. Once that's installed, you should be ready to go. So now that we have SBOM Workbench up and running for the first time, what we need to do is actually configure the SCANOSS API key. To do that, go into File in the top left hand corner here, click Settings. Beside the knowledge base API, click the plus button to add a new endpoint, and then enter your SCANOSS API URL and also mention your SCANOSS API key. If you don't have a key, then leave this as default. It will scan against the free public OSSKB that works perfectly for getting started. Now that you've configured SBOM Workbench, you can scan your first project. On the right hand side here, you'll find the option to scan for a new project. You can either click it directly or use the drop down arrow to choose from the following options. The options are new project to select a directory of the project you want to scan, import workbench project to load a previously scanned project saved as a zip file, import from WFP to import a winnowing fingerprint.wfp file, or import from raw results file. So load the output from a previously scanned file, which is a .json file. So I'll be scanning a new project, so I'll just go ahead and select that, and a window will pop up to actually select the location of the folder that you want to scan. So I'm just selecting mine here. So after selecting your project, you can adjust the scan configurations as needed. So the first one here is project name, so you give your project a descriptive and meaningful name. You set the default license for your project, if applicable. You configure your SCANOSS API key, so I have mine, so I'm going to select mine here. You have the option to integrate with SBOM Ledger for advanced tracking if required. You have the option to decompress archives and scan inner files. You have the option to obfuscate paths, enable high precision snippet matching, and include all file types. So bypass default extensions for filtering to scan all files, including configurations and documentation files. On the right here, we can see pipeline stages, file/snippet scanning enabled, dependencies enabled, vulnerabilities enabled, cryptography, and search index enabled. Once you have all that configured, you can click continue to start the scan. Once the scan is complete, you'll be brought to this detected tab right here. At the top, you'll see your summary metrics, how many files match to known components, dependencies found in your manifest files, the total vulnerability count, cryptographic algorithms detected, and the license landscape as well. These numbers give you an immediate risk snapshot. So a critical CVE count here is to queue your investigation. Clicking into vulnerabilities, we can see the full table with CVE identifiers, severity ratings, the CVSS score, the affected components, and the publication date. Moving forward, we have the license section here, which gives you a summary of all the licenses detected across your MASH components. Then you have the license obligations section, and you can use this section to view any licenses that may conflict with your project's licensing strategy. Then you have the MASH components section, and this is open source components that SCANOSS engine identified in your codebase. You can also click into the dependencies section here, and that's the declare dependencies section underneath, and these are all the dependencies listed in your project's manifest files. Moving on to the cryptography section here, this section displays the total count of cryptographic algorithms detected across your entire project. So here you'll see two tabs that separate cryptographic detections by source. So you'll see local cryptography, which shows you the local cryptographic algorithms detected by analyzing your source code files locally. This represents cryptographic usage in your own code base. And then you click into components cryptography, and this shows you the cryptographic algorithm found in your matched components and dependencies. This represents cryptographic capabilities provided by third-party libraries and components in your project. So if we go back and head over to the detected components section, this is where the real auditing happens. Your MASH files are grouped into component cards. Each card represents one open source component and all the files in your project that match to it. So we can expand these to see the individual files as well. Clicking into a file, it'll open this code viewer, and hovering over the top here, you'll see the Perl, the version, the license, the URL of the file it matched to, as well as that you have the match type here. And you can use this information to judge whether the match is legitimate or not. If it's a genuine open source component that you're using, you can click identify here. And this will bring up a dialog which is pre-filled with component name, version, Perl, and license. And you can adjust any of these and know and document your reasoning for it, and then click identify at the bottom here. If you've identified the file by mistake, you also have the option to remove your identification, and I'll go back and give you the option to identify it again. So if the match is a false positive, so it's your own code that happens to resemble some open source code, you can click mark as original here, and that file gets excluded from the SBOM entirely. You can also go back in your decision here by clicking restore. So for me, I'll actually identify this as the API Go component by clicking the green check right here and then clicking identify. Going back here, we can see that a file moved from pending to identified. I can switch these tabs right here, and we have an originals tab as well. So you can also watch the file tree on the left update as you work on these files. And you can use the snippet filter and file filter at the top here to look at different match types. So instead of going through it one by one as well, you have the option to identify all of these components by clicking the identify all button and then clicking identify. Now I won't be doing that in this video, but you have the option to do that. If we go back again, we'll have to do the same thing for dependencies. So if we click into the dependencies section and you click on a manifest file, you basically review each of these declared dependencies and either accept or dismiss the dependencies based on the matches that you're given. You can also accept all of them or individually go through them. Moving along, we have the search keyword section right here, and this is particularly useful for finding license declarations. So if you search for a license or copyright or GPL, that'll load any file that contains that snippet of code. So as you can see right here, searching for GPL, we have GPL highlighted here, and we can go through all these files and we can see the same thing. So it's also used for locating specific components, so searching for library names or imports, compliance auditing, so finding files with specific legal terms, code pattern detection, so search for any technical keywords or custom searches, any text pattern that you need to locate. You can actually use this keyword search section right here and it'll find that term. Moving on to the cryptography search section right here, which allows you to filter and find files containing any cryptographic algorithms. As you see, there's a number of keys here and you can click into them, select the key you want. Now I have all selected, so it'll show me all of the files containing these keys. As you can see here, if I click into SBOM.json, this opens the file in this code viewer. Clicking into one of the files, the file opens in a code viewer. All the cryptographic algorithms are highlighted, as you can see right here, on line 52 and line 57. And we can see above here that it mentions the lines where the cryptographic algorithms were found. So moving over to the identified components tab. This identified components tab basically mirrors the structure of the detected tab, but only shows you the components and files you've explicitly reviewed. So if I only reviewed one coming from API group. So as you can see, I reviewed one component here. Clicking into it, we can see that it's a file, version 1.1. We can see the license. If we click on view files, we can see that it's version.sh, which is the one that we've reviewed together. So once you're satisfied with your audit, you can navigate to the reports section right here. And this tab only shows you the components and dependencies that you've explicitly reviewed. From here, you can click export, which allows you to export the file in several formats. So CSV containing the SBOM cryptography vulnerability, the SBOM in CycloneDX with vulnerabilities, SPDX-Lite. You can also export the HTML summary and the SCANOSS S.json settings file. One thing to know is when you're exporting SBOM, it's different from exporting the entire project. If you want to archive your entire audit workspace, all your decision notes and history, you have to use the export project option instead. And the way to get to that is if you go to the home section right here, and you click on the export project button right here. This saves your file as a zip and you can share it with your colleagues or continue what you've done at a later stage. And that's pretty much it. That's the complete SBOM Workbench workflow from a raw source directory to a fully audited exportable SBOM. Thank you so much for watching.